Adding and subtracting polynomials. Now the funny thing is, I really think that these are quite a bit easier than multiplying. So the main type of problem to start is adding polynomials, and we'll be told to find each sum. Now I'm going to rewrite this, and I'd say go ahead and do that just so you'll follow along too. I see these first set of parentheses, but there's no multiplication to the left of it or anything like that, so it really doesn't matter. So I see 3x squared, and to make it stand out, I'm going to make that stand in purple. That's a term to the second degree. We have an x squared. The next thing I see is minus 4x. And then lastly, plus 8 in that first parentheses. So I've rewritten all of this, and now I have an addition symbol. So I'm going to add on this entire other trinomial. So I am going to write plus 2x, but I want to make this stand out and match the other one. So here's plus 2x in blue, and then minus 7x squared in purple, and then minus 5. I won't bother rewriting this again, but I could, where I would have the x squareds first, and then the terms in blue with just the x, and then 8, and then minus 5 lastly. But instead I'm just going to see this, and I see the term out in front of x squared and the minus 7. Well, you've already combined like terms, so I would get minus 4x squared for that. In front of the first x I see is negative 4 and then a 2. So negative 4 plus 2 is going to be minus 2x. And then lastly I have 8 minus 5 to give me minus 3. Now these problems, if I were doing them on a test, I would totally just try to, rescan the original and see if I could get there. So here's 3 minus 7 gives me negative 4. Negative 4x, positive 2x gives me 2x. And then 8 minus 5 gives me negative 3. So on these you have to keep an eye out for subtraction symbols, addition symbols, and make sure that if you have a problem where you have to distribute a minus, you're doing okay there as well. Now this one I won't color code it, but I will just, clear the parentheses, 5x squared minus 3x plus 4. But this time, the positive is just going to distribute, which won't change the value. But I'm going to write minus 3x squared so that it's in an order that I kind of like, plus 6x minus 3. So the thing to keep an eye out for is as you shuffle this around, you have to keep the subtraction that was with it. Okay, so I got 5x squared minus 3x giving me 2x squared. And then I can combine negative 3x and 6x to get plus 3x. And then I have 4 minus 3 as my constants, giving me plus 1. So 2x squared plus 3x plus 1. And these also can be typed into Wolfram Alpha, and the odd problems can be checked in the back of your book. So those were the two addition problems that we were given. So now let's find each difference. So I'm going to pinch and zoom here. I got 3n squared plus 13n cubed plus 5n. But the thing to keep an eye out for is when you subtract, this minus is distributing to everything. So when I clear these parentheses, it's going to become minus 7n minus 4n cubed. Now if this was a minus symbol before we distributed that negative, then it would turn positive. So basically on these you're making them the opposites. So I'm going to write minus 7n plus 4n cubed. I'm sorry, minus 4n cubed. Okay, now I'm scanning through because I'm going to try to write these in descending order So I'm looking for the highest degree polynomials first. And I see 13n cubed and 4n cubed. So 13 minus 4 is going to give me 9n cubed. I keep scanning, and I see 3n squared, but I don't see anything else with n squared attached to it, so I'm going to add 3n squared. I go back to scanning, and now I have dealt with the 3, the 2, and I'm ready to deal with just the n's to the first degree. So I'm going to write 5 minus 7 to get minus 2n. Final answer's there. We can box that. Same comments as before. You could redo the whole problem, but you can keep an eye out for it, plug it into Wolfram Alpha as you're learning this new stuff. Make sure that it all kind of makes sense. If we had had a number out here like minus 2, then this would become minus 14, and that would become minus 8. So they will get more challenging. So now I have a new one, 4x cubed minus 3x squared plus 6x minus 4. That is in descending order for me, where I have an exponent of 3, 2, 1, and then if you wanted to think of it, there's your x to the 0 power. And when I go ahead and I distribute this minus to all of those 3 separate terms, make sure you can see that those are 3 terms because they are separated by a plus and a minus symbol here. So when I go to distribute that subtraction symbol, I'm going to instead be adding 2x cubed, because a negative times a negative is a positive, or I can just think of it as flipping the signs. And then I'm going to distribute this minus to the x squared, and so I'm going to write minus x squared. And then I'm going to distribute this negative to that negative, so I'm going to write plus 2. Now I've color-coded this so it'll stand out, but I look for my highest degree with x, and there's my power of 3, and I will write 6x cubed. And then I scan through and I move on to anything with x squareds, and negative 3 minus x squared is going to be negative 3 and a negative 1, so I'm going to write minus 4. And then I see only one thing with an x, so I'll write plus 6x. And I'm doing a lot of jumping back and forth with my eyes, making sure I'm not leaving anything out. And then negative 4 plus 2 is going to leave me with a minus 2. And sometimes you can think, well, okay, I had 2 things become 1, 2 things become 1, and then 1 thing, and then 2 things become 1. And you can actually count up and just make sure nothing disappeared. Depending on the length and size of the problem, I may or may not do that. When I go through and I look through this final time, I double check to make sure that it's like 3, 2, 1, and then just a constant, so it's written in descending value for the exponents. And then I also double check to make sure that there's nothing else that I can still combine, like did I leave something out in a step. So everything that was in the first line showed up, everything that was in the second line showed up, and nothing disappears and leaves the problem. I'll stop this video here before moving into the word problems. So this is how you are going to be adding and subtracting polynomials.